So you probably learn to just find the biggest number they have in common and divide by both of them. Is that the way you learn that?
Yeah, so the way I look at that is, okay, so 8, so then it becomes 4 eighths, and then it becomes 2 fourths, and then it's 1/4 or 1/2, whatever it is. But like I keep like breaking it down.
Okay, so which number do you want me to use first to break it down? Which number am I going to divide the top and the bottom by?
I usually do 8, so
Okay.
be 4 and 6.
And then we're going to use
2.
Sorry. So this would be 2 over 3.
Mm-hmm.
Okay. When you're doing algebra, quite honestly, the easiest way to do this is to break it into its factors. So if I have 32 here and I have 48 here, then what I'm going to do is I'm going to break these two numbers down into their prime factors. I want you to get used to looking at the numbers this way, because when we start adding letters and stuff when we're doing algebra, this is actually how stuff cancels. So if you can see it with a regular number, then you're going to understand it when we actually do it with letters. So there's a method to my madness. So this is 8 and 4, and this is 8 and 6. And then I can break the 8 down into 4 and 2, and this would be 2 and 2. And then I can break this 4 down into 2 and 2. That's called a factor tree. So at the very bottom, these numbers, all of these 2's, are called prime factors. Have you heard that term before?
Yes.
Okay. So when I'm writing the top number, I'm going to write the top number like this. So this is going to be 2 times 2 times 2 times 2 times 2.
Because that's how many 2's you've got, right?
Yeah, because I have 5 2's here at the bottom of my trees, right? And then I have 5 2's there.
Okay.
Then I'm going to do the exact same thing with 48. So this would be 4 and 2, and this would be 3 and 2, and then this would be this would be 2 and 2. And so I'm going to underline the prime numbers in blue.
I don't see you writing that. I don't know if it's somewhere.
Okay, you see there's a 4-way arrow over on the.
Okay, got it. I had to open up my screen. Sorry.
No problem. I just want to make sure you get it. So you can see all these numbers now?
Yes. This is a very silly question, but is there a difference of what you start with? Like how you said you've got 8 and 4 and then 8 and 6. Do you have to start with the 8 because that's the number that would fit into both of them, or
no?
Is that you thinking about that?
Okay, let me show it to you this way. That's a good question. It's not a dumb question. So I could also take 48 and I could break it up into 24 and 2, right?
Gotcha.
And then I could break the 24 into 4 and 6. And then I could break the 4 down into 2 and 2, and then this into 2 and 3. So if I look at the numbers at the bottom of the tree, I still get the same numbers, right? I have 4 2's over here, and I also have 4 2's over there.
Okay.
So it doesn't matter what two numbers you start off with. Just know that once you have the number broken all the way down, you're going to get the same numbers anyway.
Okay.
So then I'm going to take those numbers and I'm going to write them the bottom here. So this is 2 times 2 times 2 times 2. And then it would be times 3.
So you always have to have the smaller numbers first and then the larger at the end?
It doesn't even matter the order. It really doesn't. Because you're doing multiplication. Multiplication is called commutative. So it doesn't matter the order in which you write numbers.
Okay.
I'm doing it like this on purpose. So fractions work this way. Whatever the top number is, and this is considered to be a bottom number, if you see a number on the top and the bottom, then you can cancel it. So that means that this 2 is going to cancel with that 2. This 2 is going to cancel with that 2. This 2 is going to cancel with that 2. And this 2 is going to cancel with that 2. So whenever you have the same thing on the top of a fraction as you do on the bottom of a fraction, they cancel. So
I've done.
You got a question?
No, I just remember doing this back in the day. It's been a very long time.
Well, that's why I'm going over, so you can refresh your memory. So you can see that the only 2 numbers left are 2 and 3. And that's exactly the same as the answer that we got before.
Mm-hmm.
So remember that tops cancel tops and bottoms cancel bottoms. I'm sorry, tops cancels bottoms. That's what I should say. So if I have something that looks like notice I changed the order, right?
Mm-hmm.
What 2 numbers are going to cancel?
The 5s.
The 5s. So that fraction would be equal to what?
4 over 7.
Right. And that's the technique that I wanted you to learn.
Okay.
So you can, when you're doing fractions, you can either do it this way, or you can break the number down into 2 sets of numbers and then just cancel the numbers that are the same on the top and the bottom. That's what I wanted you to see.
Okay.
I'm also going to show you this. So I'm going to use the same number. Give me 1 second.
By the way, you did not send me what your stylus and pad look like.
I sent you a...
Oh, did you?
Did I send it to the wrong person? Uh-oh. They probably were like, what the heck? Sorry.
Let me
I'll
find
send it to
out.
you now, because I could have sworn that I sent it.
It's very possible because all of your emails go into like a group email, so I may have skipped it at some point.
Okay. I'll just take it again.
I did not mean to interrupt you. I'm so sorry.
Oh, that's all right. It's not even a big deal. I want you to have this. And okay, I sent it to your phone. Did you get it this time?
Let's see.
Oh, it still says sending.
Oh, it's okay. All right.
Okay.
I'll let you know. I'm sure it'll come through.
Do you have an iPhone?
I do.
Okay. It might be 45 minutes from now.
Okay.
For some reason, when folks text me from iPhones and when I text them back, there's like this huge delay. There's been some of my students that have texted me telling me that they were running late, and then we're like halfway through our session, and then I get the text. So
Right.
it's a weird thing. So let's practice this skill.
Okay.
I'm going to erase this. And okay. So here's your number. Oh, I wanted to show you one more thing. This is kind of an overview of what we just did. This is something about exponents, and I didn't want to forget to do this. We had 5 2's before, right?
Right.
So I can write that as 2 to the 5th power.
Mm-hmm.
And then I had 4 4's, or 4 2's, and I can write that as 2 to the 4th.
Gotcha.
So when I'm simplifying this, whenever I'm dividing, so this that line means division, I can just subtract the exponents.
Okay.
So
it's 1 2.
Go ahead, say that again.
So like 1 2, obviously, because it's the 4 2's would cancel out each other.
And that 2 belongs up top because that's where the biggest one was, right? So I have 1 2 there, and then I have this 3, and so I still simplified the answer.
Okay.
That's another way of looking at the exact same question. And again, that's another skill that you need to know for algebra because you need to know how exponent math works.
Okay.
And let me ask you a question. Do you know your exponent rules? Do you remember those?
No.
Okay. Then we'll go over it later.
Okay.
I guess it's really simple. I can tell you now, like division means subtraction, and then multiplication means addition.
Okay. I remember that. I remember hearing that.
Okay, so let's do this one. So I'm going to do my 2-factor tree. So I have 36, and then I have 216. Can you tell me the two numbers that multiply together to give you 36?
6. So that's 2 and 3. 2 and 3.
And then I'll help you out on this number because this number is big, unless you already know it. Do you know it already?
No.
This
I need
is
a calculator.
Do you have a calculator there?
Yeah.
Oh, okay. Well then, prime factor it for me.
Okay.
It's an even number, so what number can you start with?
I don't know. I mean.
Okay, well, then I'm going to say this out loud. All even numbers are divisible by 2.
Okay. So start with 2 is what you're saying. Is 108. And I just keep going down.
Yep.
So 27. No. 27 was the last one I could divide it by 2.
Tell me what you're doing.
And then you have to do 3 times 9.
So 27 times what is 108? I guess is what I'm asking.
Oh, hang on.
Okay.
4.
Okay.
And 3 and 9. Okay. And the 3 and 3. 2 and 2. So 2, 3, 3, 2, 2.
Okay. So our top number has 2 times 2 times 3 times 3. And then our bottom number has 2 times 2 times 2 times 3 times 3 times 3.
Okay.
You see the 3 2's
Mm-hmm.
and the 3 3's?
Yep.
And now we just get to canceling. So That 2 and that 2 cancel. That 2 and that 2 cancel.
So it's just 3.
Well, I'm going to keep on canceling, okay? So I can't cancel this 2 because I don't have another one to match, right? But these 2 3s cancel, right?
Oh, okay. Sorry.
That's okay. And those 2 3s cancel.
Mm-hmm.
So when you are canceling in a fraction, here's the other thing. You don't get left with a 0, you get left with a 1. Because what I'm literally doing is making forms of 1. This is 2 over 2, which is 1. This is
Right.
2 over 2, which is 1. So when you cancel with a fraction, remember that you get left with a 1 if there's nothing left up top.
Okay.
And then I have these 2 numbers left. So what's 2 times 3?
6.
And so this would be that.
Okay. And then,
Then you're done.
okay.
Okay?
All right.
Okay, I'm going to show it to you a different way. Okay? Because I always like to give you options. And this is something that we can actually practice too. So this 36 is 6 times 6, right?
Correct.
So I'm going to write that as 6 squared. Do you see where I got that from?
Yes.
And now I'm going to show you this number. What are those 2 numbers multiplied together? What do they give you?
6.
What do these 2 numbers multiplied together give you?
6.
What do these 2 numbers multiplied together give you?
6.
So how many 6s do I have all together in 2a16?
3.
So I'm going to write that with an exponent. And we just talked about this. When you are dividing, what do you do to the exponents?
You subtract.
You subtract. Notice that this one has the bigger exponent, so that's where I'm going to put the answer. So what is 3 minus 2?
1.
1. So this is 6 to the first power. Do you get that part?
Wouldn't it just be 6? Do you have to put the 1?
You can yeah, you don't have to put the 1. I was just making sure that you know it's a 6 there. And there's
Okay.
a 1 over that. And when you cancel everything on the top, what does this 6 change to?
1.
So you get the same answer.
And so you're saying even if it's on the bottom, you always subtract the biggest number from the smallest one?
Yes.
The exponent? Okay.
And then the answer goes where the biggest one was.
Gotcha.
Does
Okay.
that make sense?
Mm-hmm.
So if I have, just to clarify, what would that be equal to?
1 over 7 to the third power, or?
Perfect. Yes, that's it. That's all I want you to do. Yep.
Okay.
So you got that. Are we good with the factoring stuff and the prime factoring and that sort of thing?
Yes, I just have to do it, but yes,
Okay.
I get it.
Well, I'm going to give you some to do. You can work them out there, and then I'll tell you whether your answer is right, since you don't still have the picture of what I'm actually using.
Okay.
And it says it was sent, so hopefully you got my picture.
I did get it.
Okay. So let's practice this. So if you go to the fractions comp packet that I sent you,
Okay. Fractions comp packet. Gotcha.
and go to page 8,
Equivalent fractions with smaller denominators.
this
Or
one says
improper
equivalent
fractions.
fractions with smaller denominators. That's perfect. Yeah. These are our practice problems. Once you understand it and you feel like you have it, we can move on to something else. So you only have to do as many of these as it takes. Okay?
Okay.
So I want you to start with number 1.
So 28 over 50.
Mm-hmm.
So don't do it that way. So bring these down to the trees. Which is 2 times 25, 5 times 5. Which is 2 times 5. 2 times 14. 2 times 7. 2 times 7 times 2. I may have gotten this, but I don't think I did it right.
Just tell me what you got.
14 over 25?
Yeah, that's right.
Okay. I can show you my work if I need to.
If you get it wrong, then we'll deal with your work.
Okay.
As long as you keep on getting them right, I don't necessarily need to see your work. I
Gotcha.
do want you to practice that skill, so I'm glad you are doing the prime factoring because it's going to help you later on in life.
Okay. So number 2, 8 over 24. So you have 2 times 4, 2 and 2, which is 2 times 2 times 2. 2 and 12, 2 and 6, 2 and 3, which is 2 times 2 times 2 times 3. So it's 1/3.
Good.
30 over 54. 2 times 15. 3 times 5. So that's 2 times 3 times 5. 54 is 2 times 27, 3 times 9, 3 times 3, 2 times 3 times 3 times 3. So that's 5 over 9.
Good.
Go back.
Scale
8.
1 to 10, where are you right now?
Pretty good. I think I got it.
Okay.
It's more work, but I get it if it helps me later on.
Right.
But I haven't written them into the powers, but I mean, these are all, 1/3, 14 over 25. So I mean, they're you wouldn't be writing them into the power, right?
Right.
I just don't know where I would be writing that or when, but.
Let me give you an example of why I'm showing you this. Let's say we have and I asked you to simplify that.
The top number, is that a +4 or a -4
It's
or
a plus
14?
4. It's a plus 4.
+4. Okay. And you said to simplify that?
Mm-hmm.
I've done this. I have no idea where to start, though.
Okay. When we dealt with the regular numbers, what did we do to the regular numbers? We canceled the ones that we saw that were exactly the same on the top and bottom.
Right.
The parentheses represents a number, right?
Okay.
So do you see a set of parentheses that are exactly the same on the top and the bottom?
Yes.
And tell me what's exactly the same on the top and the bottom.
The 5x and 4.
The 5x plus 4. So because we worked on that factoring skill, we can recognize that this number and that number cancel. And so your answer would be 3x plus 7 over 2x plus 7.
Oh, that's so easy. Okay.
And that's the reason why I'm teaching you the skill with numbers, because we're going to use the exact same stuff that we learned with numbers with stuff with letters in it.
Okay.
So even if I do this, that's a 7, by the way.
Okay.
I can still use that exact same skill that I taught you before with exponents. So are the top and the bottom exactly the same?
Yes.
So what
Except for
do I
their
do
power.
So it's what?
You just have to subtract the powers.
You just have to subtract the powers. So tell me what to write over here then.
It's 5x plus 4 to the 4th power, because it would be over 1, so it just cancels out.
Yeah. See how that works now?
Yep.
So algebra is the exact same stuff as the regular math. It's just that this formula represents some number. That number could be 27, and it would still be the exact same math.
Okay.
Okay. So now I'm going to do this. Let's say I have so this is kind of the next level of stuff. Okay?
Okay.
Now we have two fractions, and that dot means multiplication.
Uh-huh.
And so if I see two fractions, anywhere that the number is the same on the top as it is on the bottom, I can cancel the two numbers out. So which number can I cancel out?
The 25.
That's called cross-canceling. And it only happens when this is multiplication in between.
Okay.
Okay? And now I can change this 64 into 8 times 8, right?
Yes.
And now I have another number that's the same on the top as it is on the bottom.
Mm-hmm.
So I can cancel this 8 and that 8.
You have 1/8.
And that's equal to 1/8. I never, ever, ever want you to multiply until you have simplified the fractions and cross-canceled. Multiply at the very end because the math will be easier.
Okay.
So that's another reason why I showed you what I showed you before, because when the questions get harder, we can actually use the same skill.
Okay.
So let me see where that is in this packet, and then we'll practice some of that stuff too. We'll do the improper fraction stuff later. Okay, never mind. They're going to make me show you how to do an improper fraction first, because all of these questions have improper fraction stuff in it. Okay. Well, let me just teach you that now. Okay. Actually, I want to do two things. It's just so much stuff. Okay. Maybe you might know how to do this already. Do you know how to write that number as an improper fraction?
You have to multiply 7 times 2.
Uh-huh.
So that's 14. And then the 3 goes underneath.
The 3 gets
Or you
added.
add 3.
And add
So
3.
7 times 2 plus 3.
Uh-huh.
And that would be 17
And then this number stays exactly the same.
over 7. Okay.
So do this one for me.
Wait, 5 over 6. So that's 18 plus 5 is 23 over 6.
Okay, one more.
So 11 times 2 is 22 plus 8 is 30 over 11.
Okay. So, okay, now I am on page 16.
Oh, okay.
And the title of it is called Multiplying Fractions.
Okay.
Okay. So, tell me what the first 2 fractions are that we're supposed to be multiplying, so I don't have to look back. Are you there yet?
Yeah. So 4 and 1 over 2 times 2 over 3.
Okay, so the first step is to change this into an improper fraction. So change that for me.
So 9 over 2 times 2 over 3. The 2's cancel out. You can break down the 9. So it's 3 and 3. And so it would be canceled out by 1. So it's 3 over 1, which is 3.
Good. All right. Well, I don't have to teach you anything. Just do a couple of those then.
Okay. All right. So number 2, 3 with 1 over 5 times 1 over 4. So 16 over 5, 5 over 4, cancels that out. With those, so 4 times 4, so that cancels out, so that's 1/4.
You got 1/4?
4 over 1, I'm sorry.
There you go.
So 4. Number 3 is 6 times 1 and 1 over 9. So that would be 6 over 1 times 10 over 9. Those can be 3 times 2 and 3 times 3. That cancels out once with the 3, so that's 2 over 1 times 10 over 3. And then is it 12 over 3, which would then be 4?
Multiplying. So multiply straight across now that you reduced.
Okay, so 20 over 3. And
then
do you want to do an improper fraction? Or
can you change that back into a mixed number?
yeah. So it'd be 6 and then 2 over 3.
Good.
Okay. And that's the answer,
And
right?
That's the answer.
Okay.
I want you to do number 9. If you do number 9, actually, I want you to do number 10.
Okay.
And then if you do it correctly, then we'll just move on to something else.
Okay. Okay, so that is...
It's 7 and 9/10. Did I read that right?
Yeah, 7 and 9/10. So yeah. So 79 over 10 times 5 over 4. The 10 can be 5 times 2. So that turns into 1. So that's 79 over 2 times 1 over 4. And 79 divided by 4 does not equal anything, but I should break down.
After you're done canceling, just multiply straight across.
So 79 over 8. And then you can break that down. So I guess I would just keep that as 9 and 7 over 4.
7
over 8, I'm sorry.
It's all right.
7 over 8.
We good?
Yeah.
Okay. Then I want you to try this one. And this is more typical of the question that you're probably going to see on your entrance exam. Oh, that's not helpful.
Okay. Okay, so I can cancel out the 5s.
Yes, good.
And I can break down the 6 for a 3 times 2. That cancels out the 3. I can break down the 4 of 2 times 2. That will break down that 2, correct?
Yes.
And then I can break down 4 times 2 for the 8, and that will break down another 2. So then that is 9 over 28.
Good. Awesome.
Yeah.
You got it.
Okay.
That makes me happy.
Good.
Now, would that have been a hard question for you before?
Yeah, I wouldn't have even known where to start.
Okay.
Again, like once you show me, I can do it, but I will struggle if, say, you show this to me next week and I haven't been doing it the whole time, which for the test, I should be obviously practicing before I go take it, so I should be okay.
Okay.
It's just once I haven't looked at it and I haven't been shown that exact formula, then I'm like, what do I do again? But that's why I'm doing this, so.
Right. And that's why I'm kind of showing you it a different way, because if you know those techniques, it's going to make your life easier in the long run.
Right. Okay.
Okay. We're building trust here. Okay. Because I'm going to do some really weird stuff. And you're going to be like, what? I just want you to know that there's a method to my madness.
Gotcha.
Okay. All right. Let's deal with the addition and subtraction stuff now. Okay. So let me grab an example question. Just FYI, I'm going to show you this, but I'm sure you already know. Okay, so I'm actually going to probably show this to you in a different way, some way that your teacher didn't do when you were a kid learning this stuff.
Okay.
If I have because all of these numbers are the same, when I'm simplifying a fraction, I can just write the number once.
Yeah.
Okay. And so then all I have to do is just do the math with the numbers on the top. So that would be equal to what then?
9.
And then, we can write it as a mixed number, blah, blah, blah.
And then 1 and 1/8. Yeah.
Right. So if you were to see something like this, the same rule applies. What should I write as my denominator?
5x.
And then what would my numerator be?
21.
So even if there's a letter, as long as the stuff on the denominator is exactly the same, we just write it once.
Okay.
Okay? So just keep that in the back of your mind, because we're going to be doing stuff with fractions later on, and I'm going to show you how to get rid of a fraction so you don't even have to add fractions anymore when we actually start doing equations. Okay? So I'm not going to bother doing the ones that are exactly the same. But if I have something that looks like this, what you've been probably taught is to get a common denominator.
Yeah.
I'm going to show you something different.
Okay.
Okay, so this is a pattern that you can use in order to simplify the amount of work that you have to do. Okay, so what I'm going to do is, and I'm going to do it in this order. It has to be done in this order. I'm going to take this 8 and I'm going to multiply it up to the 3. What's that equal to?
24.
And then I'm going to take this 7 and I'm going to multiply it up to the 5.
35.
I'm going to take this sign and keep it exactly the same between the two numbers. And then I'm just going to multiply straight across to get my common denominator.
56.
Now I do the math with the numbers up top.
So negative 11 over 56.
And that would be your answer.
All right.
Have you seen that before, that pattern before?
I think I did, but when I took my preliminary math class, so.
Okay.
But.
Okay, so I want to practice that then.
Okay.
I'm just going to erase this stuff and leave the pattern there just in case you need to refresh your memory. And this pattern works for either addition or subtraction. It doesn't matter. All right, so let me choose some stuff. I'm on page 13.
Okay.
I even want, okay, so I'm going to do number 1 and I'm going to do it both ways. This is the last example I'm going to do for you. So this is 7 over 8 plus 3 over 4. Is that what that said?
3 over 4, yeah.
So probably the easiest thing to do is to change the bottom number to 8, right?
Right.
So did I have to do anything to the bottom number to make that number 8?
You have to multiply the 4 by 2, which you would have to do.
This is very, very, I'm doing this, there's a method to my madness because we're going to use this later in algebra. Okay?
Okay.
Did I have to change the 8 at all in order to write the 8 over here? So
No.
the 8 that I circled, did I do anything to it?
No.
So I don't do anything to the number up top. I just keep it exactly the same. Okay?
Okay.
Now, how do I change this 4 to an 8?
You have to multiply it by 2.
So I have to do that to the number up top.
Which is 6.
Okay. Sign stays the same in the middle. And then, so this is 7 plus 6 over 8. And then that would be 13 over 8. Okay.
Hang on, I'm just writing it down.
Okay.
Okay, 13 over 8.
So whenever you don't do anything to the number, that is the greatest common factor. So, or the greatest common denominator. So you just don't change the number. You just rewrite the number. And then whatever you do to the other number, you do to the top number.
Okay.
That's the pattern that I want you to recognize because we're going to use it later. Or I can do it this way. 7, 8 plus 3 over 4. And so I'm going to use my pattern. What's that times that?
28 plus 24 over 32.
Add the two together.
52 over 32.
And now we got to reduce.
So 1, and that's 20 over 32, which you can actually break down if you needed to.
Break it down.
We use a 4, so it's 5 over 8.
Huh. Did something go wrong here? Oh, this is 1 and 5. Okay, duh. That's the same thing.
Okay.
I was having a brain fart. Sorry. Because we changed it to we didn't change it to a mixed number here. I'm like, what? But that's right. So when the two numbers have something in common, you're always going to have to reduce. When the two numbers don't have anything in common, it just becomes the answer. So it's kind of easier to do it this way when the numbers have something in common, and it's easier to do it this way when they don't. Does that make sense?
Yeah.
Okay, so let's do a couple of these questions now too. By the way, each one of those packets on fractions has different example questions in it. I'm just using this particular packet for today. But I sent you like 2 other packets with like adding, subtracting fractions and multiplying fractions stuff too.
Okay. And then do you want me to like complete all of those by the next time that we do our session, or?
You are a grown woman. You can do as much or as little as you want.
Okay.
It is up to you because I figure you're invested, so you're going to do as much as it takes to learn it, right?
Right.
If you run across something where you're not getting the right answer, then we can cover it the next time we see each other. That's the way it's going to work.
Gotcha.
I am your helper. I'm your partner. I'm not your teacher. I'm not your boss. So you're grown.
I just want to follow the rules. You get made fun of all the time about that.
You sound as bad as my wife. I am definitely like outside of the lines type of dude, and she is not at all.
Right. Just follow the rules. Just do the right thing. That's what I tell people. Just follow the rules.
Okay, so I will ask you to. I'm going to choose the ones we're going to try. Let's just say that. So the first one I want you to try is number 5.
Is that 15 over 24?
Yep.
Okay. So 15 over 24 minus 10 over 27. Okay, so this one, because I can't make them the same, I am just going to do the cross multiplication.
Okay, I'm going to help you do this one.
Okay. I could break it down with the 3s, right?
Right. Does that reduce?
Yeah.
So reduce it first.
Okay. So that's 5 over 8.
And then this one doesn't reduce, right?
Right. 27. And then you cannot make those common, so then that's when you start doing it?
Right. That's why I
Okay.
chose that question, so you would see that part.
Okay. So you would multiply 27 times 5.
You're more than welcome to use your calculator if you want. I don't care.
Don't you worry, I am. 135. And then, so that would be minus 80 over 8 times 27 is 216. 135 minus 80 is 55 over 216. And I'm assuming you want me to break that down?
Well, you can. Break it down into its prime factors. I don't care. See if there's anything that cancels. I don't think there is, but it's a good lesson to do. So, what two numbers multiply together to give you 55?
What, two numbers?
Uh-huh.
Multiply 5 times 11.
Right? So that's what's on the top. What about the bottom? We already did this number before.
2 times 108.
Keep on going.
And then 2 times 54. 2 times 27, which would then be 3 times 9, which would then be 3 times 3. So,
Write it exponentially. How many 2's do you have?
if I am counting the one on the top for 2 times 108, right?
Yes.
So then it's 1, 2, 3. So 2 to the times 2 times 2 times 3 times 3 times 3. And then I mean, it's just 5 times 11, so I don't know if I'm doing anything on the top at all.
Well, do you have any numbers that match the top and the bottom?
No.
No, so this is our answer.
Okay, so 55 over 216. Okay. Okay.
Okay.
All right.
Let me choose another one for you. I'm going to go easy on you. Do number 4.
Three over 7 plus 2 over 5. Those cannot be the same. And I do not have to reduce them, so it's 15 plus 14 over 35, which is...
Ooh, it's fast. Go ahead, girl.
29 over 35. And that's the answer.
And that's the answer. Like that, don't you?
I love doing this stuff. I do.
I don't think I'm going to get to percentages today because we have like 6 minutes. Do you have any questions on anything that I covered today?
No. It's good.
Clear?
Clear as can be.
Good. Can you try number 12 and then I'm going to let you go?
Okay.
That one's going to be actually good practice to use a skill.
2 over 3 plus 1 over 21 minus 2 over 7. So they all can be 21. So you have to multiply that 3 by 7. So that would be 2 by 7, which is 14 over 21 plus 1 over 21 minus 6 over 21.
Okay, now look at how I wrote mine, because that's the skill I want you to use.
Oh, okay. Sorry.
That's okay.
Okay. So 14 plus 1 minus 6 over 21. And then that's 15 minus 6, which is 9. So 9 over 21, which can be 3 over 7.
Good. Okay, so like I said, you can do as much or as little on fractions as you like. Here's the only other thing that I'm going to show you today.
Okay.
We might as well do division. Now, the rule for division is that you multiply by the reciprocal. So this front number stays exactly the same. And then this one flips. So I'm going to put multiplication here, and then I'm going to flip it.
Okay.
And then I'm just going to use all the skills that we've already used today. So finish that problem for me.
So 7 goes into 49 7 times. So that's 3 over 1 times 7 over 6. And then 3 goes into 6 twice. So that would be 7 over 2, which is 3 and 1 over 2.
Good. So now you can practice doing all of the division stuff. Just remember that if there's a division symbol in front of it, you flip it.
You gotta flip it.
Here's the other way that this can be written.
Oh, that's just ugly.
I know, but it's just the same thing. So what I teach my students is just to write it side by side. That means division.
Yeah.
So you can write it just the way that I wrote it over there.
Okay.
So just write it side by side, flip, and then multiply.
Okay.
That's all I got for today.
Okay.
I think this is enough. We'll start doing percentages the next time we see each other, which will be. It's up to you.
So I didn't take my vacation, so I have to go to work now. I have to go to work now. And then, I mean, obviously Monday's a holiday, so I don't want to do anything on that day. So we can, Wednesday's actually a perfect day.
So let's just say Wednesday at 10:30 until you tell me different.
Okay, so Wednesday at 7:30 my time. Right. And that's the 7th. What day is that?
Should be the 3rd, I think.
Hold
on.
Okay.
Am I right about that, by the way?
Let me look.
It's Wednesday the 1st.
The 1st.
Is that okay?
Yeah. So let me put that in then.
Doing the same. If you get a second, it would be a huge service to me if when they ask you to write a review, you write a good one for me.
Okay.
And then submit it for me. That would be really, really helpful.
On the
on the thumbtack.
On the app? Okay.
Yeah. Because I just started using that app, and so I only have recommendations from people who actually haven't hired me on it yet. So that would be really helpful. Okay. I hope this was helpful to you too, clear and everything.
It was.
And the setup is okay?
Yeah, I'm totally okay with this. This is great because honestly, like I'm literally gonna go to work now, so this is great. I was up, I had breakfast, I had oatmeal, it was great.
Well, enjoy your holiday. Don't work too hard. I'm sorry that you didn't actually take it off. I guess maybe you can save it up for something really nice later.
That's why I actually took it. So I canceled this one because I just booked a trip to Europe for September. So
Wow.
it was last minute, but it was like for me to go from New York to Rome, from Rome to London, and London and back to New York, it's only like $760.
Oh my God.
So I'm like, yeah, I'm gonna go to Europe instead.
Well, enjoy it.
Yeah, it'll be good. So I just have to make sure I get all this done before I go.
We'll get there. I appreciate that you are a quick study and you are amenable to stuff, even though it looks more complicated, because you can actually see the benefit. That's cool.
Yeah.
Always easier for me. And
I will get my tablet and pen by Wednesday. So okay, thank you so much.
All right, you're so welcome. Have a good weekend.
All right, you too.
All right, bye.
Bye.